All right, guys. So we're going to talk about 18.1, which is our 18, Earth, Moon, and the Sun. So we're going to talk a little bit more about each one. Today we're going to do 18.1, Earth, shape, and orbit. So since we were actually able to start traveling into space, our knowledge of Earth and its moons has grown tremendously, of course. Their shape is almost a perfect sphere, except for a slight bulge at the equator. So your diameter is how wide it is across, circumference is how around it is, and radius is half of your diameter. I'm not expecting you to know these exact numbers, so... the sun is not at the center of the Earth's orbit. Like we talked about, is slightly elliptical. Because of this, the distance changes ever so slightly. So in summer, we're 153 million kilometers away, so a little bit more than an astronomical unit. Here we're 150, here we're a little less, and here we're also a little less. So remember, the tilt of the axis is really what gives us our season, not our distance from the sun. All right, compare the Earth and the Moon. The Moon is about the quarter the size, and its mass is 7.3 times 10 to the 22nd, which you're not going to remember off the top of your head. Okay, so we can see here, far less gravity, far less in mass. It's less dense. Its rotation is about 27.3 days, which once again gives us our moon, like the whole moon, half moon, crescent moon, no moon. The same side of the moon faces the Earth at all times. So, you ever hear, the dark side of the moon, it is much colder and cooler, so that side is always facing us. It rotates a whole lot slower than the Earth does. So, where did the moon come from? Before the Apollo landing that began in 1969, there were three main theories. The moon split off the Earth, the moon formed somewhere else and just kind of happened to get caught in Earth's gravitational pull. The Earth and the moon were formed together. So, the Apollo discoveries gave rise to the giant impact theory that is now more or less widely accepted. So, something massive collided with the Earth. Materials from the Earth, mantle and crust are broken off. Some of those materials reform and bundle up, get up together, all right, over time, and eventually they are put into orbit around the Earth due to its gravitational pull. Features of the moon: craters. These are large round pits that cover much of the moon's surface, usually made by meteorites hitting the surface. Some are just there. You can even see them on a clear night when the moon is close to us. You can see some of the craters with the naked eye. The brighter areas are called highlights because they are higher in elevation. Maria are low, dry areas that were flooded by molten lava probably billions and billions of years ago. Something I think a lot of us know, but just a little something to talk about. The daily cycles and the rise and the fall of the tides are controlled by the moon. If the moon passed overhead every 24 hours, we would expect the tides to rise only once a day. However, we know it's not the truth. They rise and fall twice a day. As the Earth revolves around the common center of the mass, the oceans on the opposite side are flung outward every 12 hours. So what that's saying is So here we have the center. The oceans will be flung out a little wider from here because of the Earth's the moon's slight gravitational pull. So that's going to pull that out a little ways, and as it rotates and as we rotate, we end up with tides, 2 tides a day. We end up with high tide and low tide twice a day. If you've ever been to like Jekyll Island, that's where me and my family go. You get 2 tide cycles per day. And that's really it for this one. Make sure to take notes and turn them in. Thank you so much.